Hi guys, in this video we're going to have a look at inequality regions. So this is basically how you plot inequalities on a graph, and what it will usually say is shade the region that satisfies these particular inequalities. So before you watch this video and give this a tackle, make sure you've had a look at my previous video of plotting straight lines, because that is very useful in how we tackle this. So definitely have a look at that before you watch this. And obviously if you've seen just what inequalities basically mean, so again the inequalities video, that would also help understand what these symbols mean here. If you've watched those two videos, then you're in the right place, because we're about to crack on and have a go at this. Right, so first one here, if I want to draw this, the first thing I'm going to do is imagine it is just x equals 1. Okay, so if I was to plot the line x equals 1, it's going to be a vertical line going through the x-axis at 1. Okay, so that's what I know it's going to look like. And with the inequality, it's no different. It will be a vertical line going through 1. However, we do need to bear one thing in mind. It is not going to be a solid line. We only draw a solid line when it's equal to. So like this symbol here, when you have that little line underneath the inequality, which means equal to, then we draw a solid line. When we don't have it, we draw a dotted line. Okay? So in this case, like I said, vertical line going through 1, but because it's not equal to, I'm just going to draw a nice dotted line like so. Okay? So just to recap, if it's equal to, solid line. If it's not equal to, we draw a dotted line. Okay? And all this inequality means is x is bigger. Remember, we always point at the smaller number. So x is bigger than 1. So the question will probably say, shade the region that satisfies that inequality. Well, there we have our line at 1. These x's, 2, 3, 4, are bigger than 1. So that's the area we would shade. We would shade in this area. I'm not going to shade the whole thing in because you get the idea. Okay, that is the region that is satisfied by that inequality. Okay, let's have a look at this one. Exactly the same idea. I'm going to imagine it's just x equals 3, which will just be a line going through the x-axis at 3. This time, as we've just said, it is equal to, it's got that little line, so this one will be a solid line, not a dotted one, like so. Okay, and again, what does the inequality actually tell us? Well, this time it's pointing at x, so x is smaller than 3. Well, all these values of x are smaller than 3, so if I was to shade in that region, it would be everything here. Okay, so that side of the line, because that's everything that's less than 3. Okay, so there's the basic rules. If you have the inequality line, solid line. If you don't, dotted line. And of course, as with everything, it does get slightly trickier. So what you could have is something like this. So we've got y is less than 2 and y is greater or equal to minus 3. So there's two things here. I wrote this down underneath because this is how it's usually written, which is basically those two combined. So we said that x is greater than minus 3, greater or equal to minus 3, but it's less than 2. So those two just mean the same as that, and that's generally how we write it. But I'm going to tackle it as two individual lines. So again, if I treat this as y equals 2, it will be a horizontal line going through the y-axis at 2. It's not equal to, it's just less than, which means it's going to be a dotted line. So let me just draw that in first. Like so, there we go. And y is less than 2, so all these values of y are less. So I'm just going to draw a little arrow just to show it's all less than that. Don't shade anything in until you've done the other line as well, because you might mess it up. And then this one here, again, just imagine it's y equals minus 3, so that's going to be a horizontal line going through minus 3. It is equal to, so that's going to be a solid line. Happy days. Like so. And y is greater than minus 3. So all these values are greater than minus 3. So it's everything above the line. Once you've figured that out, obviously you can then shade in everything in between the lines, like so. Okay. Right. Let's step it up just a little bit. Just move these about. There we go. Okay, so let's start combining a few more. So in this case, x is greater or equal than minus 3, but it's less than 1. And this one here, y is greater than minus 4, but it's less than or equal to 2. So actually there's 4 different inequalities to draw here. Okay, so take it step by step. Let's pick the first one here, where x is greater or equal to minus 3. So this is going to be a vertical line going through minus 3, because imagine it's just x equals minus 3. Is it solid? Yes, it is, because it's equal. X is greater or equal to minus 3. So I'm going to draw a nice solid line to represent that bit there. Then we have x is less than 1. So imagine it's x equals 1, which is going to be a vertical line going through the x-axis at 1. Is it a solid line? No, it isn't. There's no equals there. So this one's going to be dotted, like so. Okay, and then that's that top bit done. And if you want to put your arrows in, probably a good idea. X is greater than minus 3, so it's anything this side of that line is greater than that. And then x is less than 1, so it's going to be anything that side of the line. So essentially we're looking at this area at the minute. Don't shade anything, because we've still got these to do. Y is greater than minus 4. So imagine it's just y equals minus 4, which is a horizontal line going through the y-axis at minus 4. Is it a solid line? No, it isn't. There's no equals, so it's dotted. So I'll put that in now. And we're saying y is greater than minus 4, so all these are greater than minus 4, so it's going up that way. And then finally, y is less than or equal to 2. So again, imagine it's just y equals 2. So it's going to be a horizontal line there. Is it going to be solid? Yes, it is, because it's equal to. Okay, and y is less than that, so it's going to be below that line. And you probably already guessed it. The bit that we need to shade in is this rectangle that we've made here. Okay. Right. So that's what happens if you've got nice straight vertical and horizontal lines. Let's have a look at what happens when you have diagonal lines. So y is less than x. So again, just imagine that is y equals x, and just plot that. Well, you should know what y equals x is. It's just a point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. If you watched my previous video on straight lines, that is one that we talked about. Is it going to be a straight line? No, it isn't. It's not equal. It's going to be a dotted line. So let's line up our points there. So we're going to do dotted lines like so. And that's that one. This one here, imagine it is just y equals minus x. Okay, like so. Just imagine it's equal to. And again, you should know this one. It's exactly the same thing. It's a diagonal line, but this time it's going the other way. Whatever y is, so if y is 1, x would be minus 1. If y is 2, it would be minus 2. So it's a diagonal going the other way. So just line those points up there. Is it solid line? No, it's not. It's going to be dotted again. Sorry, let me just get my points there. So 4 minus 4. There we go. Just makes it easier to line up. Like so. There we go. And the last one, x equals to 3. Which is just like we've just been doing before. So it's going to be a solid vertical line going through the x-axis at 3. Is going to be a solid line because it's equal to, like that. There we go. Excellent. Okay. So x is less than 3, so it's going to be this way. Y was less than x, so this was that line. If y is less than x, it's going to be below because it's less than. And this one, y was greater than minus x, so it's all the y values will be greater, so it's going to be up that way. In which case, if I shade that region in there, I've answered that question. And the last one, just to be a little bit trickier, okay? Again, just imagine it's y equals 2x minus 3. So if I just come down here and write that out, okay? Just as if you were plotting a straight line, just get yourself a few coordinates. I'm just going to go 0, 1, 2, 3, just to get a couple. Okay, quick flow chart. I have x, I times it by 2, I minus 3, and I get y. So just a refresher of that's what that video on plotting straight lines tells us to do. So let's imagine x is 0. 0 times 2 is 0, take away 3 is minus 3. If x is 1, 1 times 2 is 2, take away 3 is minus 1. 2 times 2 is 4, take away 3 is 1. 3 times 2 is 6, take away 3 is 3. So once you've got that, you can start to plot a few of those in. So 0 minus 3, 1 minus 1, 2, 1, and 3, 3. Don't draw a solid line yet, because notice it's an inequality, so it isn't equal to, so that line needs to be dotted. So you can line it up with the points you've just put, but make sure, because it's not an equal, has that little equals line underneath, this line does need to be dotted, okay? And y is greater than this, so it's going to be all the y values which are greater, so we're going to shade in everything that side of it. Okay, let's have a look at this one. Now again, from the plotting straight lines video, there's a quick, easy way to do this. If we say x is 0, so x is 0, what does y need to be? Well, y needs to be 1 to make that work. So x is 0, y is 1. Let's put that point there. Same trick, imagine y is 0. What does x need to be? Well, x needs to be 1. Okay, so if x is 1, y is 0. So you can put those 2 points there. Again, just do points. Check. This is an inequality where it says it's not equal to, so this needs to be a dotted line as well. So we can line up those points there and draw our dotted line like so. Okay, and x and y are both less than 1, so it's going to be down this way. And last but not least, x is greater than minus 1, so just like we've been doing over here, nice solid vertical line going through minus 1 is going to be solid because it's equal to, so I can put that in like that. Okay, and x is greater, so we're looking that way, and then we can just shade in our region. Just do a very quick rough shading in like so. Excellent. Okay. So that's if you're given the inequalities. What happens if you're given the diagrams and you need to write down the inequalities? Good question. Let's give it a go. Okay. Right, so here we have 2 diagrams, okay? This one here hasn't got the lines all the way across, it literally just has the shape. So what you could do is extend the lines. It's entirely up to you. If that helps you, you can do that. And here we just have the lines extended and just the shape shaded here, okay? So what we're going to do, vertical lines, okay, is x. So we have x, and x is bigger than this one here, which is at minus 2, and x is smaller than 3. So that's the easiest way to do that. Just stick your x, stick your inequalities, and go the smallest number, biggest number. Don't forget though, solid line means equal to, so just make sure you look at that. That's a dotted line, so don't have to worry about that one. That can just stay like that. Then we can do our horizontal lines here, which are the y's. Again, stick your inequalities in, okay? What's the smallest y value? Well, it's minus 1, so y is bigger than minus 1. What's the biggest value? It's 4, so y is less than 4. That's a solid line, so that needs to be equal to, that's a dotted line, so we can leave it like that, not a problem. Okay, and that's it, you're done. Not a problem, those ones, nice and easy. These ones aren't. These are a little bit trickier. Okay, so this is where you'd be finding the equation of a straight line. The video for that would definitely come in handy, but let's do the easy ones. A vertical line here going through -1, which means I'm going to have x and I'm going to have -1. Okay, now x is bigger. This is the bit, this side here is shaded, so x is bigger. 0 is bigger than -1, 1 is bigger than -1, and so on. Okay, so x is bigger than -1. That's the first thing. It's a solid line, so we must remember to put that little equals line there. Okay, so that's that bit done. These ones here, okay, slightly trickier. To do that, we need to find the equation of the line. So remember, the equation of a straight line is just y equals mx plus c, where m is the gradient and c is the y-intercept. To work out the gradient, pick two coordinates on the line. I'm going to pick these two, but you could have picked that one, you could have picked that one, could have picked that one, could have picked that one. And we just draw our right angled triangle like so. The change in y, 1, 2, 3, 4 squares. Change in x, 2 squares. And the gradient, which is m, is just the change in y, which is 4, divided by the change in x, which is 2. So the gradient in this case is 2. So I'm going to substitute that into there. Y equals 2x. And where does it cross the y-axis? It crosses at -3. Okay? So that's the equation of this straight line, but we're dealing with the inequality. Okay? So if you're dealing with the inequality, we have a look. What's shaded? Well, above the line is what's shaded, in which case y must be bigger than this line. -2 is bigger than -3, -1 is bigger than -3. So y is greater, which means it needs to point at the rest of this. Okay, y is the biggest thing, and it's a solid line, so remember, equals. Okay, and that's how you do that one. This one here, you might remember, we've already done this one. This is y equals -x. Remember, y is 1, x is -1. Y is 2, x is -2. Y is 3, x is -3. So this one here is the y equals -x. We need to get the inequality right though. And this time the y values, so if here I have the y value 0, -1 is less than that, -2 is less than that. So y is less than, it's smaller than that, okay? So we just need to say y is less than. This is a dotted line, so I can leave it as that inequality there, okay? So just a quick recap with these. If you have nice vertical lines, brilliant, use your x's. If you have horizontal lines, brilliant, use your y's. If you have diagonals, you might need to work out the equation of the line, just like I did here, and then just work out what the inequality is, whether y is bigger if it's above, or less if it's below the line. And then finally, if it's a solid line, make sure you put an equals, and if it's a dotted line, just make sure you leave the inequality like that. Okay, and that's how you work out inequalities and shade the regions, guys. Hopefully that helps. Thanks for watching.